match name, we match water. Is this too loud? Am I shouting? This is an SM58 microphone. It has a proximity effect, which really makes things very, very cool for shouting down the loud people next door. All right. Okay, I am from Datawire. My name is Brian Kelly. My colleague Abe is here with me too. And we are a microservices technology company based in Boston and San Francisco. We provide end-to-end solutions for microservices by dealing with your existing technology stack. But what I'm here to talk to you about is about building microservices. Now, why do you care about listening to me about microservices? What the hell do I know about them? Well, I've been listening to people who've built them. Our whole company has. That's what we've been doing for the last year as we were bootstrapping. We've talked to Netflix, Facebook, Google, Uber, Yelp, you name it, and we've asked them how they've gotten through these tough problems. See, they're already quietening. This is great. I want to show of hands. How many people have deployed over 1,000 microservices in their organization? Okay, wow, we have 2 hands. All right, less than 1,000, like say 100. Okay, we got another hand. 10. Okay, so pretty much we're running the gamut here for that. The thing to know about microservices is they're deliberately simple on the inside, but it's really hard on the outside. It's kind of like a weird caramel confection thing. And why is it hard, right? It's hard because cloud applications are continuously uptime, distributed applications. They are distributed systems. And distributed systems are? Hard. Thank you, that's right. Every component's got to be hot swappable. You've got to have resilience for people who screw up, for machines that fail, just like Brian mentioned. And you've got to coordinate or choreograph all these things towards a single application purpose. I'm going to move this. Did I just? Okay, we're okay. So it's hard. And there are a variety of concerns. So here are the 3 categories of concern I'm going to go through. I wrote a blog post recently, and this is what I sort of loosely based this presentation on, which is about 10 questions you should ask yourself before you create a new microservice. And these 10 questions are actually categorized as follows. There's organizational concerns, architectural concerns, and some developmental concerns or more technical concerns. So let's start with organization. Number 1, if you're about to create a microservice, have you invested in developer infrastructure? How many companies that you work for, how many people have developer experience or developer infrastructure teams? 1 hand. 1.5 hands. Fingers, sort of. Okay. What are developer infrastructure teams? They are the team that focuses on developer education, core infrastructure, DX basically is a thing. All of those big masters of microservices, the Googles, the Netflixes, etc., have built teams that then output artifacts and collateral and whatever to assist everybody else in the organization in building the microservices. You mentioned an RPC library earlier. Somebody had to build that, and somebody has to maintain it and push it out and do all that. Well, a developer infrastructure team is a lagging indicator of high-quality microservice architecture, because the moment you realize you need one, you've got a shitload of microservices. So investing in the core infrastructure for independent iteration, the cycle of microservice creation, is absolutely key. You've got to have loosely coupled services. Don't build a distributed monolith. Bad idea. You got to have a workflow. Be it Spinnaker or homegrown stuff, it doesn't matter. But things have to be continuously deployed and delivered. And you've got to build resilience. It's a distributed system. Resilience is key. So ensuring changes to a single microservice don't explode and cascade over to other services is important. And that's what you do with loosely coupled services. Well-defined contracts. That was something, I started my career with, and I'm going to age myself a little bit, with Corba and DCOM and all those distributed systems technologies, and they were all about contracts. And then we turned it into WSDL, and there was another contract. And they got a bad name. Well, you know what? Contracts are really important. How you manifest them can be different. You can have implicit contracts like, hey, don't hit my service with 500 requests a second, it's not built for that. And you go and tell someone with an email not to do that. That's an implicit contract. Or you can have explicit contracts that are IDL-based. You still need contracts. Dependencies and state need to be very carefully managed. You don't want to have an update to microservice A causing, a cascading upgrade to happen through your system. You don't have microservices if you upgrade one and you have to upgrade everything else. That's kind of dumb. Second question that you should ask yourself is, how will your new service be deployed and upgraded? And I classify this as an organizational thing. Anybody want to guess why this is an organizational, not just technical thing? You have to coordinate it and keep going. Coordinate it with whom?
People are involved, QA.
They're not, are they in the same team? No. List the teams required. QA, you mentioned, obviously developers. Ops, DevOps. Finance, exactly. Release managers, product managers, cross-functional. It's an organizational concern. So we see, this is an infographic Datawire put together recently. This is the cycle of deployment and upgrade. And it just keeps restarting. You probably can't read it. So coding and defining your contracts, actually implementing the service, is such a minor part of microservices. Then you've got to build your jars, your packages, whatever, your binaries. Then you bake that into a container, an AMI, Docker, whatever. Then you deploy it, Kubernetes, whatever, you're scheduling it to get pushed out. You're still not there. Then you have to monitor it, and I think we have some really good solutions in Prometheus for that. That's very, very interesting stuff. And then other services are going to consume it. So now you've got connectivity. And then you start all over. Oh, crap, we need to add another API to that service. Let's code it. Let's increment the contract or amend the contract to do that. And you keep going. And there's a whole set of technologies for each of these stages. Now, Datawire, we're down on these two right now because they're pretty underserved, and we think we're actually got some interesting offerings there. But we'll just keep moving on. The whole point of microservices is what? Can someone name one word that tells the room the benefit of microservices? Like you want to say to your CEO, we're going to do microservices because scalability, keep going. Composability, keep going. Flexibility, more. Velocity. All of those things you said are valid, but they're a secondary objective. Right? What they allow you to do is go faster. And you want to iterate, go from commit to customer as quickly as possible. You can't do that with a 10 million line monolith that takes a 6-week QA cycle for somebody to click through every JSP and torture themselves with every cross-browser testing by hand. So the whole point of this is velocity. And you've got to have a clearly defined workflow and an ability to have that pipeline, that deployment pipeline working, including tests, all the way through to monitoring. So that's deployment. But now let's talk about upgrading. Who here is scared of upgrading their microservices? All right, I see one hand. Yeah, 2 hands, 3 hands, 4 hands. All right. Why are we scared of upgrading our microservices? Because of breakage, right? Change is breakage. What was your dependencies? Right. So every upgrade, I love that. I wrote this thinking it was negative, but it kind of comes off sounding positive. Every upgrade is a chance to break everything. It's like, that's true though. You really don't know with 100% certainty, do you, if you're going to break stuff up or downstream. What you can probably do is get, with investment, as close as possible to converge to 100%. But that investment is proportional. So there's lots of techniques out there for this, and let's look at them real quick. Actually specifying your contracts is really good. Don't leave it to chance. Has anybody ever added a field to a JSON, object and just said, well, I'm just adding a field, no one's using it, right? Additive fields should be okay. How many people have done that with XML? Why don't you do it with XML? Because people still run those frickin' XML schema validators that watch for extraneous fields and complain when they see new stuff. Like, that's the worst idea possible, but it happens. It happens in financial services all the time. So adding new fields, you think, oh, it's fine, no one's using it. Oh yeah, you just broke the box that does the XML validation thing. It's a horrible idea. So having those contracts specified and versioning them and dealing with those changes is a critical way of managing your upgrades. Dark launching. Anybody ever done dark launching? All right, so it's a really cool technique. It sounds like you guys have some good experience in it. But examining the effect of production traffic. Now, you might do that by just copying the production traffic and fanning it out to two endpoints, old and new, and then just watching how things go. That's good. But there's a cool technique at Twitter. Anybody here from Twitter? Okay, good. Can I make fun of them? I won't want to. They're nice guys. Twitter uses a technique called response diffing. Has anybody heard of this response diffing technique? All right. So I should have drawn a picture, but basically, you take 2 copies of the existing service and 1 copy of your new upgraded service, and you take traffic, like say a single request, and you multiply it into the 3, copy and paste, the request goes into all 3. And on the way back, all 3 replies or responses are examined and compared to each other. If the 2 existing service replies are absolutely identical, and the new service is different, you have a bad situation on your hands because the new service is now responding different. But there's heuristics involved. And the reason why there's 3 servers in play for this test is what will happen is if the 2 existing services disagree. So the identical copies are already different. What's probably going on there is there's ephemeral data, timestamps or something, that's not terribly critical. That means if those 3 responses differ in the same place, in the same field, and they differ in the same way, you're probably okay to let that upgrade fly. So it's an interesting technique. Now you've probably heard of canary testing, blue-green deployments. All of these things, it starts here with preventing failure, and it gets progressively towards mitigating and being able to roll back. But they're all important techniques. You need the spectrum. Now, I'm going to do a pretty crappy job compared to Brian's monitoring thing, but there's some interesting overlap here. You have to know ahead of time, how the hell are you going to monitor and measure your microservice? Don't bother deploying it if you can't measure it, because you can't improve what you can't measure, right? So there are ways of monitoring your service's health. A very, very, I'm being generous here, an okay way is you have an ELB and it calls into your endpoint with /health and expects a 200 OK. How many people have implemented this health checky endpoint, right? It's so popular. How many people have implemented the method to say return, OK, right? Yeah, right? We all do that. How many people ran a complete business transaction all the way to the database as before they returned 200 OK? Aha. No, you didn't do it. OK. So a better approach maybe is calling home. I won't get into the pull-push debate here, but the service itself, might be able to call home and give health checks, and I won't go further into details because we've covered that already. But what is the best approach? And I mean this let me ask that question better. That's too subjective. Which entity in the system of microservices is the best determinant or the best entity that is most suited to figuring out if a service is dead, sick, or alive? The clients, exactly. And why is that? Because that's the real thing. The whole point of building a microservice is to make those APIs successful. So you may as well trust their intuition on it, because they're the ones actually getting the service. For diagnosis, the big wigs in the microservices world typically monitor the traffic as well as the services. And this is where you get into cascading failure detection, and what service is starting to increase latencies, causing back pressure, etc. All right, moving into development, how will you test your service? Does testing scare anybody with microservices? Yeah, well, it's like a whole different world. So in the monolith, we had this luxury of unit testing. Yeah, you spin up the monolith in Eclipse or whatever your IDE is, you run the tests, and it's like, hey, I can ship. Isn't that great? And then you move to microservices, and it's like, I just physically cannot run the system anymore. There's too many things, too many different languages, etc. So how is a developer expected to verify that their changes to their microservice isn't going to break everything else? Well, the initial naive answer is staging environments. I've done them. Can we shame ourselves? Who's done a staging environment, right? Does anybody like staging environments? No, nobody likes staging environments. Why? Because they suck. They feel comfortable, right? It's like this, you can tell your boss, you know, a non-technical boss, hey, don't worry, we've a complete replica of production. Well, you replicated everything except the important thing, which is what? The traffic, the data, like the actual usage of the system. And unless you're going to start completely duplicating production traffic over there, you're wasting your time. It adds cost, complexity, and most of all, distractions. So, with testing in a microservice environment, you have to cover the spectrum of before and after launch. Before launch, mock services. You know, some sophisticated deployment workflows to bring those mock services and other things into play. Automatic regression tests. Then you deploy. You're still not done with testing at deployment, and that's the big shift from monolithic development. Post-deployment, you've got to watch for you know, the impact of any failure. Dark launching gets you some testing without really launching. Canary testing is proportionally bigger and bigger amounts, and blue-green gets you rollback. Okay, this will be very quick. How will the microservice be secured? Has anybody been asked to secure all the microservices? And make sure it's all secured, it's HTTPS, and those are not self-signed certificates, right? Right? Let's look at the potential attack vectors for your microservices. What is likely going to happen is some script kiddie is going to try SQL injection and cross-site request forgery and XSS and everything else, and they will try and break it the easy way. And if they can't get in that way, some internal staff who already has access will do some stupid stuff to your system. By accident or maybe maliciously. And then, you know, somebody will call the receptionist and say, hey, it's Bob the CEO, can I have my password again? And someone will say, oh yeah, sure, here you are, Bob, right? With social engineering, it's very hard to defend against from a technical level. You got to train your staff. What's less likely, and probably least likely to happen, is the matrix scenario where some super duper anonymous hacker is going to jump in and get into your system right behind the gateway, figure out how to log on to all your stuff, then magically reverse engineer all your APIs and then send fake requests to your microservices. It's not going to happen. Or at least if it does, you've got bigger problems because someone's in your system and they've got full control. What is more likely to happen is these things. Focus on these. If you're a bank, I'm sorry, you're going to be focusing on this too. Sucks, sorry. But if you're not a bank, maybe you should consider. So I would recommend don't do HTTPS behind the gateway. HTTP, make it simple. You don't want to deal with certs expiring on a Sunday night at 4 a.m. Okay, let's talk about configuration. How will your new service be configured? 3 basic categories of configuration that we've seen. Static configuration, which is, you know, very basic system level stuff. Where do I put stuff? Where do I listen? Runtime configuration, which is more how do I handle certain kinds of or certain amounts of traffic? Thread pool sizes, heap sizes, you name it, stack size. And then behavioral configuration, which is very dynamic and related to deployments, turning on or off features, request routing. For configuration, please deploy into immutable containers. Is everybody using immutable containers? It's okay if you're not. Just take from this that you should go home and stop, you know, mucking with your containers. What it means is, if you want to make a change, or if ops or anybody wants to make a change to a container, they got to copy the existing one, make the change, and bake a new one. And that way, you get massive predictability and clarity around your containers. Don't let people jump onto Docker images and say, I'm just going to hack a little bit on the file system. In the dynamic sense, you can probably get to 0 dynamic configuration. Stop messing with thread pool sizes dynamically. Build an adaptive system that changes pool sizes when things increase and drops it when they decrease. And for dynamic behavioral configuration, it's really the high order of sophistication of microservices is achieved with this behavioral configuration. So be prepared for that. All right, so how will it be consumed by the rest of the system? Why did I walk over here? I'm sorry, I'm going to walk back over. I probably should have taken your clicker, but that's okay. Your microservice needs a contract. Now, I know that makes me sound like a lawyer, but I'm not. I'm a manager, so probably similar in engineers' estimations. You have to provide an SLA. Has anybody here ever specified an SLA for a service they created? Okay, how did you specify it?
Nines and latency.
I mean, okay, so that's great, actually. What was your SLA?
We had a legal plus swagger.
Okay.
Well, that was 999.
Okay, so, but how did you deliver that SLA to the people using it? How did you tell them? Was it like on a wiki or something, or emailed, or?
There was a tool that
Or in,
parsed
okay.
calls.
Was that?
Contract.
Contract, okay. So, if I'm calling Staples down the street to buy something, and the phone doesn't ring up, or someone doesn't pick up, there's a contract there for they will answer the phone between 9 and 6, right? If I call at 7, I'm not going to get an answer. That's an SLA that they publish on their website, and also when I make the call, the IVR system tells me, about the SLA. But most people, when they're building microservices, don't encode the SLA into it. The SLA is extremely important because if you're consuming a microservice, the SLA allows the consumer, the client, to do all kinds of cool stuff. They can say, I'm going to trip a timeout or a circuit breaker when response latency from your new service is too high beyond the SLA you said it should provide. So if you tell me 500 milliseconds is the upper bound for response time, and I see 2 seconds, well, your service is dead to me. I can learn which operations are idempotent, and I can reissue them. I can cache responses. Is there a cache tolerance? And I can basically spot these discrepancies that allow me to be a more informed consumer. Now we have an IDL, and actually, I wasn't going to mention that it's Turing complete, but since you mentioned your language is Turing complete, so is ours. And it's an IDL that encapsulates both structure, API parameters, and behavior. And you can basically capture how consumers interact with your microservice with this language. And then you compile it down into JavaScript, Ruby, whatever, and it spits out these stubs that capture all of these wonderful behaviors that the service author wants the clients to use. I'll show you a demo later. Okay, discovery system. Is everybody just using Zookeeper? Should I just assume Zookeeper is everybody's discovery system? etcd. Console, anyone? File system? DNS? All right, let's talk about discovery. The simpler your discovery system, the less flexibility it offers. DNS is a good starting point, but it quickly gets really, really annoying. It doesn't take into account availability, and TTLs suck. Basically, it's okay for less than 5 services, but then it gets way out of whack. And then you go all the way to the strongly consistent data stores like Zookeeper. Now they're very flexible, but God help you if you have a network partition. I see nodding heads already. This is interesting. We're not the only ones who saw this. All those big company names that I mentioned earlier, they all hate Zookeeper because of this. In a network partition, if you talk to the minority that cannot reach the majority, Zookeeper doesn't even respond. It's just like, Zook, I can't talk to you, I can't talk. And it's therefore dead in the water, or at least the minority side. Now, there's very good reasons from a database consistency point of view, but pretty crappy reasons from a system uptime point of view. We have a discovery system in the cloud, discovery as a service, if you want to think of it like that, that's eventually consistent, and it's pub/sub. We don't consider it like a store. It's a channel. The real authoritative information about discovery is in the servers themselves. Those servers are advertising, hey, I'm here, I'm awake, I'm ready for work. it's not someone else's job to record that. It's someone else's job to help pass that information along. So what we do is open up that channel, and we use WebSockets and all these kind of funky, really cool technologies to make whoever wants to be aware of it, aware of it. And that way, we can handle partitions, etc. Okay, scaling. I'm not going to talk about scaling. I'm sure you've all read, The Art of Scalability, etc. And you've done some scaling and sticky sessions that suck, etc. What I am going to talk about is a thing called the choke point sequence. And having a little bit of awareness before you roll out your first version of your microservice, what things are going to fail in what order with increased capacity, increased traffic. So I'm actually thinking really cool things about Prometheus that we could use the query language to predict that. So an example sequence, and this is fairly typical, the first thing that craps out is the database. And then people are like, all right, let's up the RAM on the database or shard it or something. And then the problem shifts. Okay, now RAM on the servers are screwed. Then the CPU is hosed. Then the FD limit is hit. And then you finally, you maxed out your ELB. You fix that with some more ELBs. And then, you've saturated the NICs. And then you just repeat over and over again. You just move the problem back and forth. But knowing the sequence is really important because then you can be aware of your headroom. And then you can use Prometheus to tell you when you'll run out of that headroom. Last one. How will dependency failures be handled? And this is the most important one. This is the distributed systems problem right here. Downstream dependencies will occur. Actually, it's even more general. Failures will occur on a frequent basis. Just get used to it. Don't fight there's a great Irish movie called The Field. I'm sure you've seen it. And right at the end, the guy is trying to fight the sea. He's trying to prevent the tide from coming in with a stick. That's you trying to prevent, your failures. Just accept them. The tide is coming in, right? You don't take out your stick. Just learn to swim. So downstream dependency failures will happen, and dealing with them is super, super important. Any microservice calling another thing, or basically any distributed system, should be using at a minimum timeouts. If you use timeouts, then you can also employ circuit breakers, a la Hystrix. We also have an implementation of circuit breakers in our technology. And those then prevent cascading failure. Because if you shut off the flow of failure, you prevent it from cascading out to your upstream services. So back pressure, when you're getting that pain from another service, you can start to respond. Default response values, bit of a dirty word in software. But if you call another service and it's sick or it doesn't respond in time, could you come up with some default values for what you thought was going to be in the response? I'll tell you what's not a good default value, an empty string when it's expecting a JSON object that you're going to try and unmarshal, right? At least create a fake JSON object that you can unmarshal. What about caching? Cache tolerance, retries, fall back to alternative discoverable endpoints. But this is probably the most important thing. Who here has tested a microservice failure by hitting Control-C and stopping it, right? We've all done it. And it happens never. That's not how microservices die. Microservices don't die, they get sick. 99.bazillion% of the time, microservices get sick. They get overloaded, they go into funky state, they do not die. So what happens is response time goes up, latency increases, etc. Or values are coming back all gunky. So that was downstream. Let's talk about upstream. Understanding what it means for the rest of the system who now depends on you, understanding what happens when, not if, when your system fails, because your system will fail. If it's a secondary logging system, like let's say you have it's not a crucial business transaction thing on the critical path, and you communicate over UDP completely asynchronously, then your service can crap out and die, and nobody upstream is really going to die because of that. There's no cascading failure. You might lose data, but certainly your failure will not percolate up the stream. However, that's not what most people are building with microservices. They're building critical in-stream primary systems, like say credit card billing or order processing or whatever. That's where you need to be careful when things do fail. Okay, let me. I'm gonna balance it there. Actually, I think I appreciate it though. If it falls and it makes a big bang, they'll just get scared. So, all right.
When it falls.
When, good, nice. Oh God, the font. Oh, the font, it's so small. You know what? This is gonna be. All right, I've got a monolith here with three instances of a single microservice. I'm going to show you some resilience techniques in action. This is why we don't do HTML and CSS. It works great, but I mean, didn't get hired at Amazon, you can tell. Imagine this is a monolith. It's a simple e-commerce app, and what we're going to do is create a new microservice called ratings that implements product ratings functionality. So we have prices, we have images. We're now going to create a new microservice that has ratings out of 1 out of 5 or 3 out of 5, whatever. So let me. Oh, I had stopped it. Let me run it there. Okay. This is a service. This is the monolith. This is the e-commerce system, and it was built using the Datawire middleware, our technology. It at this point has called to the cloud discovery service and said, "Hey, is there any rating service available?" And it says no. So if I refresh this page, you can see, you probably can't see here, I'm sorry. You can see here, there, all the rating services are down. Its downstream dependency is unavailable, but rendered just fine. No errors, we handled it. We had no downstream service availability, that's okay. We obviously did not get product ratings because there was nobody there to give us ratings. All right, so let's start. I'll just start one instance. Okay, there's one instance. The moment that started, it now registered with the cloud and said, hey, I'm here for ratings and I'm ready to take requests. So if I refresh, boom, there's my ratings. Because the monolith was told, hey, this service appeared called ratings and he's over there on this host and that port and I'm able to go get him. All right, so that was basic resiliency. Now let's use load balancing. We turn on 2 more instances. You'll just have to imagine the tiny text. Trust me, it's not fake. So now if I refresh, then I get the round robin, 2, 3, 1, 2, 3, it just round robin across them. But remember I said, this is all the naive, it's all up and running. Let's make something sick. So I'm not going to control C it, I will control.
S.
Oh, that's a good one. What sig is that?
Sig stop.
Is that the same as control Z on my keyboard? I don't know. I'm not that smart.
It's a different one.
Okay, control Z suspends it, right? But it leaves the process running and all the file descriptors open and all the connections open. So I've stopped instance 2. Officially, according to the discovery service, it's still alive. It's got a connection open. It's not heart beating, but it's still alive. So I run it, everything renders just fine. Because what we did, where is it? Oh, I can't read it. Okay, we got a timeout here, but it had another service to fall back on. Now I'm going to do something even cooler. I'm going to stop all my services. Make sure they're all dead. Okay. Now I have no ratings microservices running. What's going to happen when I refresh the page? Okay, he got it. Anybody else? Am I going to lose the ratings or not? All right, yeah, you guys predicted it. I did queue it up for you, in fairness. And you're right. I don't lose the ratings because we architected it to cache the values that we got back. Because ratings don't change that often. It's not like your bank balance. You can probably cache it for an hour or whatever. So that is how it works. And let me just make this bigger so you can see it. This is our Turing complete language called Quark. And Quark is what we use to define the service contract. If anybody's used, Protobuf or Thrift or whatever, similar to that, except it also encodes behavior. All those other technologies just say, here's what the parameters look like. Go figure out what happens at the runtime, behavioral level. What we do is we create these. bigger. Move it down. So we create these interfaces, but we also include behaviors. And you can program it here. This is what the client will call. Right now, it just does an RPC, right? Request, reply, fine. But you could also include all kinds of different things here. We've very simple ways of plugging in timeouts and circuit breakers and whatnot, and it all works out of the box. And it'll compile down. Right now, we have 4 languages supported: Ruby, Python, Java, JavaScript, and obviously we're looking at Go, even C#, because Windows, Azure sucks for a lot of this stuff. And we compile to native language. We don't require JVM all the time like other technologies, so we're very happy with it. Let me go back to my thing here. We're almost done. Let you all go home. So if you want to try it out, it's free and open source. Even the cloud discovery service, which we pay for on Amazon, you're welcome to use. Production ready, go for it. There's our GitHub address. We all work in our public Slack channel, so if you go in there and join it, you'll see our normal day-to-day workings. It's not a support channel, it's our life channel. And we also, 2 months ago, had a really cool summit in San Francisco where we invited, Ben Christensen, author of Hystrix, the microservice guys from Netflix, Uber, etc. And they came and talked, and we have a domain called microservices.com. Yes, we do own that. And we put all those talks up online. Just go watch them. They're really, really good talks. And that's it. Any questions?
So we're on the Microsoft stack, and we're looking for alternatives to Hystrix. A couple of, there's one called Mjolnir, and it's not that immature.
Right.
Where are they any good alternatives, or do you have to better?
I'll move the C# port of our stuff up as quickly as I can. No, there's really not that many good options. You've obviously had the same experience. The Azure stack is, it's great for some stuff, but not for.
No, actually, we're moving to Amazon.
Oh, okay.
It's the same issues like with other technology, obviously you have to deal with that.
Yeah. So I'm not aware of any other stuff. Ave, are you?
I know there's a company called Jet that presented here a few months ago. They're all F# or largely F#. I might want to talk to them. But yeah, I'm not aware of any good resilience solutions.
So we do a workshop with Ben Christensen, and it's pretty cool, and there's always a lot of complexity around it.
Yeah, Ben's great.
Rather than not have to do it from scratch.
Nobody wants to do this from scratch. That's why companies like us exist, so we can just do it for you. Any other questions?
Do you guys do anything about like self-healing of your microservices?
Self-healing in which
Like in a
sense?
specific instance of a microservice, like cluster scheduling or any of that.
Oh, so in terms of like auto scaling, like Kubernetes, like scheduling stuff.
Yeah, I mean, I think a really great insight that you had is that it's your clients that really know if you're healthy or not. But all the cluster scheduling technology relies on those like /health endpoints. And it'd be really cool if you could tie at your like interface layer that you guys compile for everyone. It'd be really cool if you could tie the knowledge about how many instances of a downstream dependency failed into the cluster scheduler to close the loop and actually heal those.
That's a really good point. So yes, we have the information. It's not integrated yet. I was talking recently with my friend James Strachan. Some of you might know him from Groovy. You probably know he's a big Prometheus guy. I don't know if he's in the. He's crazy about Prometheus right now, and he saw our stuff, and he's like, you got to get that integrated with that and Kubernetes. Like, get those 3 things working together, because you've got info that they don't have, they've got info that you don't have, et cetera. But the combination of all 3 is magic. So the answer, I think, is we want it soon, and definitely we'd be interested if anyone wants to do a PR for it.
Basically, that stuff is useful for getting the 5th line, maybe the 6th line. But it's that small benefit,
Yep.
at least at large scale.
Yeah.
I don't know.
So nothing is useless, but it's, it's,
Orders of magnitude, like more.
yeah, and the more important stuff, the stuff here is also, this is very much getting niche.
Yep. Well, I think that.
I don't actually think that's true, and I'll give a real world example, because you mentioned in your like /health endpoint whether you talk to the database or not.
Yeah.
Right? So if the database is down, are you healthy or not?
If you're dependent on the database, you're not healthy.
Okay.
But if you're a computational service as well as a database-backed service, then you can maybe do some things.
So this is something that we actually run into. When the database goes down, if you say you're not healthy, your auto-scaling group goes through and murders all your instances. And now you're really not healthy.
Okay, yes.
Right? So you have this idea of like, if the dependency is down for everybody, then it's the dependency that's down. If
Yeah.
the dependency is down for me, I'm probably the one that needs to be replaced. And you guys have that. That's more than the fifth nine.
This is a different problem, which is conflation of health. Because you've got your health for the person in the cluster, and you've got the health for the person your client, and then for different clients. And the problem is we all have one health.
Yeah.
Yeah.
There is no
this
one
a
health.
Much more basic issue. The issue which I thought you were asking about is, I have 20 instances, one of them is dodgy. Can you also detect that and fix it, or rather, kill it?
Yeah.
Yeah, I mean, Flappy is another completely separate thing. It's sometimes down.
Yeah. Or the issue more is, this one is slightly slower.
So to use another crappy analogy, I love analogies, especially crappy ones. If I want to go to a Starbucks, I look online at starbucks.com and I see, oh, there's a store nearby. That's literally the most basic indicator of health of that service, right? Because I have no idea if that store is available or not. I walk over there, it could have been closed down because someone found rats in the back or something, right? And then that's another indicator of health. Oh, I can walk through the door, great. At least I know the place is open. They might be closing it down, it might be the middle of the day, I don't know, but I'll know when I get closer to the counter. Then when I get to the counter, is it a trainee barista who has no idea how to make espressos and I'm going to be standing there for 20 minutes waiting forever and going to give up? Or is it a really experienced one who's cranking it out? I need information at each of those levels to make an informed decision, but it's an experiential thing. You have to actually go through that process or have someone else who's just gone through it as well relay that information to you. But it's all about that full business transaction visibility, and I think that's your point, and I agree with it, which is there's tremendous value in the client experiences with those services being used elsewhere, and they're not right now. And we are going to do that. We are going to be adding more integrations and more richness of data, or push our richness of data to other systems. Any other questions?
Just something to add on SLAs. They're also very useful for you as the supplier of a service, because let's say your service is currently lightly loaded and responding really quickly.
Mm-hmm.
And let's say you've got a 500 millisecond SLA and it's responding 50 milliseconds. When you slow down, not if, you can say, no, this is their SLA, and that's something useful to have.
Yep.
And that's actually also important at the business level as well, not just internally.
That's a great point. Great point.
Don't complain if you get a little slower.
Oh, they'll still complain. At least you can say, no.
Yep. So, yes?
At which part is the SLA formed? Is it like during, at which point do you develop that?
I think it's formed essentially at development phase, right? Now, microservices and architects don't go well together. It's meant to be about developer empowerment. So when a developer sits down and says, I'm going to write the currency converter service from dollars to euros, they've probably they're the best people positioned in the organization to have an idea about how fast that thing can go, right? Are they going to do this with a preloaded currency conversion table that they have in memory that's really fast? Or are they going to go and do a web service call to get the exact latest rate, to some third party? All of those things matter to the SLA that you can provide. So there's that. And then there's also the testing that the developer does, because people have, especially in microservices where it's this beautiful bounded context, and they want to make this thing as nice and as beautiful as possible, they become intimately familiar with how it should behave. So capturing that SLA is a developer's responsibility in our idea. If you have an architect dictate the currency converter service must reply in 5 milliseconds, well, that's not maybe a reflection of reality, and it kind of creates this weird responsibility mismatch. You should reflect back from the service's implementation what the SLA is going to be, because what you're saying is, I don't care what you want it to be, here's the bloody code. This is how fast it runs. If it goes over this, then the code is not running right, but it should be in this area here. Long answer, but hopefully that answers it. Any other questions? All right, well, thank you very much.